When Steve started the company, Ignition was built. First, it was conceptually before it became a reality to correct these problems. It's a communications hub. It connects to just about anything. We call it an industrial application platform. It offers unlimited connections. It can connect to all your PCs and devices through OPC and MQTT protocols, all major databases, historians, any MES or ERP system, and web services. Last year, we took a survey of our customers, and one of the questions was, what's the main thing that you use Ignition for? The number one answer by far was data acquisition. It lets you collect as much data from as many different sources as possible, and then you can query it, analyze it, or use it in some other way that'll end up benefiting your organization. With Ignition, you can connect to data from any PLC or device. PLCs are really the basis of most control systems, as you know. They automate electromechanical processes and are used to control machinery. They also capture data from the plant floor by monitoring inputs and outputs. Ignition also connects to just about any device used by industrial organizations. It does this through a range of different drivers and modules. OPC-UA driver modules are a group of Ignition modules that require the OPC-UA module and are focused on establishing communication to specific devices. One of the groundbreaking things that Ignition is that it has OPC-UA embedded at its core. And because of that, Ignition gives you nearly seamless connectivity to hundreds of other protocols. Ignition has drivers for major PLC brands, and it has drivers for Modbus devices, UDP and TCP devices, DNP3 machines, and Omron Controllers. In addition to those drivers, Ignition also connects to third-party OPC servers, so you can connect really it to any device. And let's just go into a little bit more depth on this because connectivity is such a critical component. In the Allen Bradley brand of programmable logic controllers, it's a popular choice in many industries. You connect these families of devices, which includes compact logics, control logics, and others, by using the drivers in our Allen Bradley driver suite. You can also connect to the Siemens Semiconductor line of PLCs with the Siemens drivers module for Ignition, your Siemens S7, 300, 400, 1200, 1500 PLCs. Addition to that, if you take a look at Modbus, in case you don't know, it's an application protocol that helps data to be managed and passed, between various layers without being affected by the protocol used by the next immediate layer. So Modbus TCP, or known as Modbus TCP IP, is a simple Modbus protocol running on Ethernet over a TCP interface. The Modbus driver allows the Ignition OPC-UA server to communicate with any device that supports the Modbus TCP protocol. It's a generic, simple driver that allows PLC support. You can collect data from laboratory information management systems, or LIMS, with the UDP and TCP drivers module. Those LIMS devices include barcode scanners, weigh scales, analytical equipment of various sorts. And the UDP and TCP drivers are configured to connect and passively listen to one or more ports on a given IP address. Rules are configured that dictate how the incoming data is interpreted. I'm going to ask each of our panelists, Kyle and Travis, maybe comment on this, but why, Kyle, you first, why is that data from scales and barcodes valuable to have in your SCADA system? In what way would it be shared? How do people use that?
Well, I mean, it kind of brings us back to what this webinar is about. It's about putting more data into one system. So, having your scale data, helps with certain processes. We've connected on a large scale open pit mine research and development project where we had to weigh all of the slurry coming in and out to get a net product, or a net volume. So we're using the scales to do that. We've connected to barcode scanners in production. It allows you to have your user, scan a barcode instead of having to type it in all the time. And we've used to connect to gas chromatographs at some of our oil and gas refineries. So when their lab equipment is done running a test, it just pushes the data into the driver, and we're able to automatically apply business rules and routing into what happens with that information.
Thanks, Kyle. Travis, your experience on that?
Well, so I mean, this is important because it's part of this integration with all the devices and information you have within a plant, and it's about how to get to them. So a lot of these is weight scales and barcode scanners may be RS-232, it may be serial, in which case it can be a little bit challenging to potentially get access to that. There's a lot of ways you can do that. Certainly you can put a MOXA serial Ethernet converter in front of it, and that can actually then we can connect to it with the TCP driver, which allows it to get that information to Ignition. So it can help for quality systems. It can help just getting more data, like Kyle was saying. So it's really about having a driver set that allows us to get to the information that's out there, and because there's just a whole variety of different devices and different protocols and just different ways that data exists in a plant.
Thanks, Travis. Going on a little further into this, I mentioned DNP3 before. The DNP3 is a protocol that's used by many electric and water utilities in North America. It's used to communicate with SCADA master stations and, of course, remote outstations. If your organization uses devices that support the DNP3 protocol, you can communicate with them by using the DNP3 driver module for Ignition. You can also use it to set up alias point lists for those devices. Connect to Omron NJ series controllers with the Omron driver module for Ignition. The Omron NJ controllers are they're used in the SysMac automation platform, so it has access to data from lots of different devices there too. And I mentioned third party before. Ignition doesn't have drivers for every device. We're not a driver company. We try to pick some major ones for a lot of our major industries, which I just went over. But it can connect to various third-party OPC servers, either through DCOM or through OPC-UA. Before there was OPC-UA, the original version of OPC used Microsoft DCOM as a uniform way for industrial applications to share data. But DCOM wasn't very easy to work with. It's kind of become outdated. But if you have legacy OPC servers that use DCOM, you can get to that data by using the OPC-COM module. And Ignition connects to third-party OPC-UA servers, such as those made by Kepware, Matricon, Beckhoff. So because of the standards that Ignition is built with, you can connect to any device. I think this is kind of the main point here. We built it on standards so you can connect to any device that's out there, either through Ignition's native OPC or a third-party OPC server. So we open the floodgates to making that data available. Kyle, we've talked about how Ignition can connect to all these different devices and protocols. How have you been able to apply these capabilities to actually be of more service to your customers?
A lot of our customers have a lot of older systems, aging systems. They might have an existing HMI platform that has the OPC DA server built in. So we've used the UA tunneler quite a bit to connect to those DA services. Anytime you're dealing with a lot of EFM data, at least in the oil and gas industry, there's some specialized communication rules that has to happen. So we've used Kepware quite a bit in our large-scale implementations. Being able to even write drivers for the inductive automation OPC server has helped us integrate with other applications that don't have a readily available communication path. So OPC is really what's empowering a lot of our ability to collect this data for our clients.
Great, thanks, Kyle. I appreciate it because I know you're, and just thanks for the comment on the ability to write your own drivers where needed to expand the connectivity where it wasn't formerly available. Additionally, to all of those devices, it can also connect to serial ports with the serial module. Ignition can send and receive information over a serial port. There are two variants of this module. One allows the system serial functions to be accessed from client-based scripts, and one allows them to be accessed by gateway-based scripts. Connect with semiconductor fab equipment by using the SexGem module for Ignition. SexGem is a standard from SEMI, which is an international organization of semiconductor manufacturers. Travis, with regard to the SexGem module, can you tell us a little more about this module and about how the data from semiconductor equipment could be used?
Well, yeah, sure. So in an automated fab, this interface, with this protocol can help you start and stop equipment processing, can collect measurement data throughout that, can change variables and even select recipes for products. So it really allows you to interface, with this equipment to host communication, and so it just opens up that another channel to more devices, more things that we can work with. So it's very important obviously for semiconductor, very specific to that. but allows you to do quite a bit in that realm.
Thanks, Travis. So looking at all that, just Ignition, as I said, has embedded OPC-UA. There are also modules for Ignition that allow it to leverage the MQTT protocol, which has become the leading protocol for the industrial Internet of Things. By building MQTT architectures that include middleware, what you really are able to accomplish is you can decouple intelligent devices from applications and instead connect those intelligent devices to your infrastructure and put the data right into your infrastructure. There are a lot more details to it. I'm going to let Travis make a couple comments on it here too, but one of the benefits is you can gather huge amounts of data from field devices that are usually just left unused. You get at those silos and you can make that data available to line of business applications. If you just look at this graphic that's up here on the left side, as I look at the screen here, you have your plant floor with your PLCs, your HMIs, your sensors, and then your field devices, the RTUs, the rectifiers, the flow computers, all of that stuff, all those edge of network devices come in through God knows how many protocols, but they can publish data into the MQTT server, and then on the other side of this, the industrial applications at the top and the business applications at the bottom, you can use it for your traditional SCADA applications, alarming, historian, but also line of business, the ERP, the billing, the CRM. So it really is a very good approach to how to really capture field device data and bring it into the enterprise. Travis, you've worked a lot with MQTT and with Cirrus Link and the development of the MQTT for Ignition modules. Would you like to add something to this?
Yeah, sure. I mean, this is a really important infrastructure change. Everything we've talked about so far as what Ignition can connect to, as far as the PLCs, the drivers built into Ignition, and OPC, in general, is very important. It's to standardize that part of it. But this is now bringing in a different infrastructure. Rather than a traditional pull response that we have with our legacy protocols, which is never going to go away, the idea is to have middleware, basically enterprise service bus for the industrial realm that's been around in IT for a long time. So rather than coupling your application with the actual device protocols, having the drivers built natively, imagine pushing all that to the edge, having them publish data to a central system that Ignition could get access to, the SCADA system, but also ERP systems, business BI tools, business analytics, ERP, CRM, billing, any other application get access to it. So it's not having to use your SCADA system as that enterprise service bus. Is to actually have this infrastructure, this change that really facilitates the future, where when we do get more data, more things they can plug and play into the environment without having to have these specific drivers. So it's really about standardization, but more around the infrastructure and with getting this information into a system.
Thanks, Travis. I really appreciate expanding on that a little bit, because this is a significant, this enterprise service bus, if you will, for industrial, is a huge necessary component if the industrial Internet of Things is going to connect to thousands of devices and sensors and bring data smoothly into the enterprise. So if you want more information on this, incidentally, you can get a lot more detail on the Ignition IIoT platform and the Cirrus Link MQTT modules at inductiveautomation.com/ignition-IIoT.